This is SOL A.7. The student will investigate and analyze function, linear and quadratic, function families, and their characteristics both algebraically and graphically, including determining whether a relation is a function, domain and range, zeros of a function, x and y intercepts, and finding the values of a function for elements in its domain, including making connections amongst all those things. Okay, given the relation B, which of the following values for x will make the relation be a function? So in this case, you're kind of thinking which of those values would make it not a function. So remember, something is not a function if the input repeats to a different output. So in other words, it can't be 4, 5, or 9. So the only one that will make this stay a function would be C, 7. Okay, what is the domain of the function graph? So this is a line that's been stopped at the x value -3. The arrow down here tells us that it's going to keep going, getting bigger and bigger and bigger. The x values are getting bigger and bigger and bigger, and it's going to keep going on and on. But it can't go any further below -3 on the x-axis. So in other words, the domain, which remember is in terms of x, is limited to anything greater than or equal to -3. So it's going to have to be C. Now, it's not all reals because of that point. Had it just been a line like this, going on and on in both directions, then it would be all real numbers. And again, y would be in reference to the range, so the domain is anything greater than or equal to -3. A function f is described. F of x equals x minus 2 squared plus 3. The domain is all real numbers greater than 0, and the range is all real numbers greater than or equal to what number? Now, if you graph this in your calculator, type it in exactly as you see it, the vertex is going to be at 3 on the y-axis. And there's no negative out front, so that's how I know it's a positive. It's a parabola opening up. So in other words, the vertex is the minimum value. So all of the outputs, the y values, are going to have to be greater than or equal to 3. So everything above 3. What are the x and y intercepts of 2x minus 4y equals 7? So remember, to find the x-intercept, we make y 0. So we get 2x minus 0, just doesn't change it, equal to 7. So the x-intercept is 7 over 2, or 3.5. Okay, and then the y-intercept, we make x 0, and we get -4y equals 7. Again, solve for y. So the y-intercept is -1.75. Okay, so that would be C. X-intercept of 3.5, y-intercept of -1.75. You could also check this by putting it into slope-intercept form, graphing it in your calculator, and then you should eyeball, is it actually going through the x and y axis at those numbers? Okay, so we are selecting each function that has an x-intercept of 3. So there's a couple different ways to approach this. One is to graph all of these, and you can type them in exactly as you see them because they're already, everything's on one side. And you can look, does it cross the x-axis at 3? The one you have to be careful of, f of x, make sure you put the top in parentheses so that the calculator knows to divide by 5 at the end. So that's one way to do it. It's just graph and see, is it crossing the x-axis at 3? Algebraically, if it's a linear function, we're trying to see if we make y 0, does it have an x-intercept of 3? If it's a quadratic, that's another way of saying, is 3 one of the solutions? Okay, so keep in mind x-intercepts. Some of these definitely have a y-intercept of 3, purposely there to confuse you. Okay. This one here, if we simplify that, we end up with -4/5 x plus 3. Now that is a y-intercept of 3, But to see if it has an x-intercept of 3, we have to make y 0. So then we end up with negative 3 multiplied by the reciprocal, which would be 5 over negative 4. 5 times negative 3 is negative 15 over negative 4. That's not an x-intercept of 3. So, and again, you could graph it to double check, but that's definitely, you're not going to click that one. Okay, now the second one, again, that is a quadratic function. Okay, so that one's going to be a little hard to factor. We could use a quadratic formula, but if you graph it, you'll see that it does not go through the x-axis at 3, so we're not going to click that one either. H of x, let's make y 0. Solve for x. Multiply by the reciprocal, which is 3 over 5, and we do get an x-intercept of 3. Okay, so that one you would click. J of x, remember, it's already factored for you, so if you set each side equal to 0, you'll see that you have an x-intercept of positive 5 and negative 3. So you're not going to click that one either. Okay, and for that last one, if you graph that in your calculator, you will see that it does have an x-intercept of 3. Algebraically, we could do slide and divide to make sure. So x squared minus 11x plus 18. And then you end up with minus 9 minus 2. Divide by 3. And you get x minus 3. 3x minus 2. And so when you set x minus 3 equal to 0, you do get a positive x-intercept of 3. Okay, f of x is x squared plus 2x plus 4. What is f of 3? Remember, when it's written like that, that's in place of x. So all you're going to do is replace x with the number. 3 squared is 9, plus 6 plus 4. 9 plus 10 is 19. So that should be A right there. In which table do the values represent the rule shown? So the square of the sum of x and 5 is equal to y. First you have to translate it. The square of the sum of x plus 5 will look like that, is y. So now you can just plug in x and see which one fits that. Well, 3 plus 5 is 8 squared, not that one. 3 plus 5 is 8, nope. So 3 plus 5, 8 squared is 64. 4 plus 5 is 9 squared is 81. So it does have to be C. Okay, this one, you are actually kind of graphing this. So you're just going to put 3 points on the grid. And there are more than one that will work. So you just have to pick 3 that are correct. First you need to translate this. 3 more than square of a number x is y. So that's going to be y equals x squared plus 3. That plus 3 tells me that the vertex is on 3. Okay, so that's a nice easy one to click. And then what you can do is just plug in x values to get a couple more points to plot. I could plug in 1. 1 squared is 1 plus 3 is 4. So at 1, 4 I can put a point. Same thing, negative 1 squared is 1 plus 3 is 4. So I could put another point right there. Now, when you're on the SOL, the pointer is only going to let you click at intersections, so don't worry about that. But where you're putting the points is what it's going to grade. There are a few more, because obviously you could plug in more x values and get other y's, but those 3, would mark this as correct. And that's it for this one.